In this part, the third part, we will go through the gateway menu and talk about the button toolbars. So in order to better illustrate the gateway, you use another model which you also introduced in one of our section, response spectrum analysis. So that there are three tabs in the gateway. If you notice, that will be tables tab, output tab, views tab. So in the table tabs, we have the titles, specification, geometry, nodes, elements, members, properties, constraints, loading, dynamic response, cases and tasks, general data. And if you have a look at the output tab, you see that most of these subtabs is corresponding to what you input in here. Okay, so we can first start from the specification. So you can edit at the title part, you can edit the job number, the job title, these things. In the specification, you can edit the units, which is similar to, actually the same to the function of these two on the units on the top two bars. And as for the geometry, one thing that need to mention is the grid plans, because if you need to define grid area or grid area load, for example, if you want to convert the south weight of the slab on, for example, 1 floor or 2 floors, you need to define the grid plan first. So what you should do is to select this, the first line, and double click or right click, use the wizard, or you can click on the wizard on the top toolbar and import, for example, name is floor 1, the first floor. So the grid elevation is the elevation of this grid plan. So you can only define this grid plan according to its elevations, and the loads applied on this grid plan will only apply on here. For example, if you have a story height of 3.5 meters, and if you want to apply the loads on the first floor, and the grade elevation you input as 4, and later when you import the grade area load, it actually won't affect on the 3.5 meters grade area, although you have never defined it. So what you should do is to define 3.5 meters, and this tolerance is the error of the grid plan. We can all leave this as default setting, and then we can generate our first grid plan. And same thing for the second one, which is floor 2, and then is the elevation. For example, the second floor there will be 7.0. Okay, yeah, so that's how we define the grid plans. Next thing will be the nodes. So you should be noticed that in the coordinates, the restraints, the supports, the numbers behind each of them is the same. Okay? This is 4, this is 4, this is 4, because I defined 4 nodes, so there will be 4 different coordinates and 4 restraints and 4 supports. So let's have a look at coordinates first. We already been calculated, so we need to erase the result. So right now we can go to graphic view and have a look. So at the bottom will be not 1, then not 2, not 3, and not 4. So that's how I defined it in here. That's the first thing you should do, is to define the nodes. And be aware that once you have defined the elements, which is this, it's not a good idea to just insert or change anything in this part, because once you do, for example, I insert a line before the line 2, which is used to be the line 1, what is going to happen is that, you see, the model changed. So actually there's only 2 elements, not 3 elements, and this element is missing because we never defined. Or for example, if you define the coordinates like 10, 0, 0, so what's going to happen? It looks like that. So it's completely different from the original model. Therefore, when you need to change something here, you should be very careful about that. And restraints is about how the node is restrained. For example, for node 1, which is at the base of the ground floor columns, then generally we fix this node, so there will be incas in all the direction. For 2, 3, 4, these 3 nodes, because in this model we want to see how it looks like when vibrate in x direction, so we only we restrain all the directions but not x. Okay, so you don't need to change anything about suppose, unless sometimes if you are building a building model, you may have to define something about the soil condition. Then at that time you may need to use this. Then before we talk about the elements, we should go to the property first, which is quite easier to illustrate things. But before that, there's another thing was mentioned, which is the interfunction of GSA and Excel. For example, right now I have 4 nodes, and if I want to have 20 nodes, so the most general way to do that is to import it by yourself. So if the figure is okay, you can just input a line. For example, here will be 19, and 0, 0, here will be 23.75, and yeah, do that again and again. However, there's a more easier way to do that, especially if all the columns or the distance between 2 nodes are the same. So I can copy them and go to Excel, paste them. So this column E, F, G will be the coordinates of X, Y, Z. So what I'm going to do is to, using the Excel, to generate 20 nodes. Okay, and then I select all these 20 lines and go back to here, paste it. Then I have 20 nodes. I don't need to import them one by one, so you see, it's very convenient. Okay, so let's move back. Yeah, and this is very helpful, especially when you need to define a lot of nodes. Yeah. Later is we'll talk about the properties. We start from the session properties. So right now, what you see here is session properties usually means the cross-section property of an element. For example, we only define one property here, which is I name it as column, because we have columns in here. That's the columns. And I choose the material as zero density concrete, which I will introduce later in the material part. But I can define the material according to the requirement. Then is the about the size, the cross-section size of this member. And generally, it's a very good idea to define it here in the wizard instead of just changing it here, unless you are quite familiar with the function of this part. So you can double click, right click to for the wizard, or use this one, the wizard, And the first is the name, the second will be the material, the third is the type of the cross-section. You can either define it according to the category or define it as a rectangular, circle, I-section, these things. And as I mentioned before, you should be very careful about the unit here, because right now it's 700 mm by 700 mm, which is solid cross-section, but sometimes some people will just forget and input a meter here, so there will be 700 meter by 700 meters members, which is super huge. Okay, and click on next. Here it shows the properties of this cross-section, that which give you a general idea about that. And if I change it to solid section, to whole sections, for example, thickness 10, 20, okay, so this will change, the property will change. Okay, so it seems I need to delete them before I change it to solid. Oops. Yeah, it's strange. So we can cancel it. Yeah. So you can see the properties of here and have a basic judgment about whether you have input the numbers right or wrong. Okay, then we can talk about the. After we talk about the section properties, we will go to the materials. So there are 5 building standard materials in GSA, which is steel, concrete short-term, concrete long-term, aluminium, and glass. Sometimes if you want to use different kind of materials, such as what I just used, the zero density material, or if you want to use a higher grade concrete, you need to define it here. Okay. For example, that's the one of the example I defined. So I can use wizard to open it. Let me first choose the elastic isotropic, or according to the requirement, and material type will be concrete. And then I import the figures here. Since the material is zero density, so the density is 0, so finished. But one more thing that need to be mentioned is that when you create a new material, for example, I want to have a different kind of grade of the concrete, so I said grade X. So I didn't change other things. I made, for example, increase in 550, which is quite huge actually. So when I finish, it's important to know that you see here the name doesn't change it. You need to re-import the name. For example, in the case it will be concrete. Great. X. So that's something that you should be aware of. If you don't change the name, it will still says material 2. So if we go to the section properties, we can have a look at the material. It says material 2. And it may get confused sometimes if you don't know what kind of material it is. Okay, after we define the material, we can have a look at the elements part, which is here. So the first column, which is column A, suggests the type of the element. So we have beam, bar spring, ground spring. Ground spring is used to model the soil in the section part of the civil structure and the underground or soil structure. And mass is, well, represent mass. Code 4, code 8, these are all represent for the 2D elements. Sometimes we may use it to build, to model the concrete walls, these kind of things. So beams is usually represent for the beam and columns in the actual model. So even if there's no column here, okay, so we name it as a beam. And for beams, we usually don't define it in the gateway manual. We define it in the most traditional way as introduced in the part 2. We use these tools, which is the add element scap tools, to link from one node to the other node. Or we use this add strings offline the element. And at the column F and column G, it shows the starting nodes and the ending nodes of the element. So that this, if you change the sequence of the nodes at here at coordinates, these two values, they won't change. For example, as I just insert one line here, in the section properties or in element, these two values won't change to 2 to 3. Okay, so that's this one. So that's very important to be aware of. As for the mass, we just defined it in here in element. And we first define the property. We can duplicate it or use wizard. And the mass, which you can name it as floor or floor 2, floor 1. Type is mass, which is 1. This means that which node is applied on. So in this case, they'll apply on node 2. So we can show that in the example. If you apply the mass here, you will have a small square to represent it. And right now, we don't have anything at 4, so we can add another mass, which represents the floor 3. And that will be the mass is located at node 4, so I put node 4 and finish. So see right now, there's a mass at node 4. So that's how you deal with element part. We don't need to worry too much about the members. As for the constraints, later in one of the sections, we will talk about the rigid constraints, which is used to represent the slab or something similar, because in the actual structure analysis, we don't consider the slab as a structure like the structure wall. So, but however, in the event of seismic effect or the other conditions, the slab actually link the beams and columns on each floor together to vibrate, to deform. So we have to define the rigid constraints to represent the slab. As for the loading part, there are nodal loading, beam loading, 2D element loading, grade loading, and gravity loading. So let's go back to when you double click that, you can go to node loads, but generally we don't define it in here. How we define it is, first we select node, and then we right click, we choose create node loading, and click here. For example, you can define the name or node, for example, seismic, and the locus is 1, direction is X direction, we want it to in the positive direction, so like 10 kilonewton, and we show the load diagram and choose L1 at place 1, and then we see the load here. Okay, and we can check the value, and sometimes we can also select 2 or 3 nodes or several nodes together and create nodal loading the same way we did, which is, for example, in X directions 15. So right now, let's have a look at it. So here will be 15 kilonewton applied on the node 3, and here will be 25 because I have already defined a 10 kilonewton apply on node 2. So that's how we define the loads on nodes. As for the beams elements, beam loading, actually the same, we don't define it in here. We may change it in here, but we don't define it in here. we select elements, right click, create element loading, and create bin load. So there are different kinds of load types, and we use uniform. The directions we can choose in X, and or in most of the cases when you are doing a model of a structure is generally in Z direction. So in X direction right now we input like 10 kilonewton per meter. So you can then see that there's 10 kilonewton per meter applied on element 2 and 10 Newton per meter applied on element 1. Okay. Mm, 2D element loading is used to apply for the 2D elements, for example, the structure walls. Grade loading, especially the grade area loading, need to be defined if you already have here grade plans. So what you should do is go to result. For example, the name will be floor 1. Grade plan you should choose which grade plan do you want to apply the load on. So means that if you want to apply grade area load, you should have already defined the grade plan. Load case is 1, or you can choose the other load cases, and you can choose the value. The thing is, because we didn't define any actual plan in here, I mean like the structure, so we can't see it, but we can see it in here, the example. So I can cut through a little bit of this part, and I have defined a grade area for these 2 floors, so we can have a look. Then you can see that that will be the grade plan, or I can show it in one floor. It doesn't show us very well. Okay, let's have a check. The loading, the grade area loading. So yeah, we have the grade area loading. Okay, now it shows. Not really, but anyway, yeah. If you apply a grade area loading, it usually shows like this. Oops. Let's see if I can back. Yeah. So for central loading, apply on here, and there are several lines to different ends, and we can have a look. It shows the value of the loads applied on here is 6.2 kilonewton per square meter. Okay, so that's how you visually check the area load. And let's go back to this model. And the last thing about this part is the gravity loading. So in terms of the gravity loading, you should know that here, sometimes when you conduct analyze, for example, the SLS case or URS, which is the ultimate limit state, for example, URS, the Z directions, which is for the dead load, should be negative 1.35. So that in URS cases, the dead load will, the load case 1 has already applied on this vector. Okay. Sometimes in this model, as in this model shows, the one we just built, you can see that in the beginning we have select including the self weight, so that in the gravity loading, it already applied a -1 in z directions, which is going down, suggesting that the program has already considered the cases for calculating the self-weight. Okay, then let's look at the last 2 bit, which is the dynamic response. Oh, you don't have dynamic response here, but you have something here. In some default setting, you won't see the dynamic response part in the gateway menu. So what you should do is to go to the menu, click on Tools, Preference, and Advanced Feature, tick Dynamic Response Analyze, and press OK. Then you can see the dynamic response here. This part will be covered in one of the sections later. As for the cases and tasks, the low cases specification is how when you specify a low case. For example, for low case 1, we define the as dead load, and type will be the dead load, and yeah, in that direction. And then we define another one, which is the live load. In low case 2, type is a live. That's okay. Check. Yep. So that's how you define low cases, because the dead load and live load, you may want to import them in different low cases, so that in the combination cases you can combine them. For example, in the SRS, there will be 1 times low case A1 plus 1 times low case A2, which is 1 times the dead load and 1 times the live load. And for the URS condition, that will be 1.35 of the dead load and 1.50 of the live load. So that will be 1.35 times low case 1 and 1.50 times low case 2. So, okay. Yeah, and then you get the different combinations. And analyze task is when you need to conduct different kinds of analyze. You can right click and click on new analyze task, or click on the new analyze task at the top 2 bars, and choose one of the analyze tasks you want to conduct. Well, in the general data, there's list, cases descriptions, and assemblies. List is the most important things here, because sometimes when you build a model, you will define the list, which is something like you select this element and you select this element, select these elements and right click, save selection as list, and for example, a column. Then you can display it, show the list as column. You will only see the columns. And go to the list here, you will see the which element number it is, which is element 1, element 2, and element 3. Name is the columns. Okay. So that will be all for the table tabs. As for the outputs, if you cover if you including this title and model statistics, history, environmental impact summary, analyze to the general data. So when you have conduct the analyze, which let's see, I have conduct the analyze call. So you can have a look at here, which is the including the dynamic response. If you have input the dynamic response, you have the dynamic response output But if you don't, for example, in these cases, or it can be analyzed, it won't have the dynamic response output. Okay? And we can have a look at another result here, which is nodal force moment. And you can have a look at the reactions of these nodes. What's important to mention that is this part is also can be converted to the Excel friendly interface, which is you press on your keyboard Ctrl, Alt, and G, and this becomes an Excel friendly document. So you can select all of them, copy it, and paste it in Excel. And then you can, based on these figures in Excel, to plot some image or some diagrams. And that will be all for the gateway part. And for the bottom areas, here, as you have noticed that I have frequently used the graphic here, which is can swiftly let me go back to the graphic view. And the first one is specification is equal to the gateway manual of here. The specification, click that. It shows the general specification of this model, including the unit, including the location, tolerance, and the nodes is nodes, element, material, and sections is according to these 4 functions in here. Okay. And gateway is open or close the gateway. Object viewer is open or close the object viewer. And default is the data default, which we have introduced in the part 1. So output is how you show the output data. For example, what we just see is the nodal force and element and moment. So yeah, in this table. As for the object viewer, first of all, let's select the element 1, and we can have a look at the object viewer. Here, it says the element 1 is start from node 1 and end at node 2. Also set in here. Position 1 is node 1, position 2 is node 2, is coordinates. And the central of this element is z in 2.375 meter. The length of this element, orientation angle, these informations and the properties, including the cross-section size and the material. So if you don't want to check them while in the gateway menu, you can just select it and check it in the object view. So that will be all for the third part of this tutorial, which is also the last part of this tutorial.